Welcome to the Gen AI Daily Briefing for Sunday, August 23rd, 2026. The most interesting thread today is that the center of gravity keeps moving away from just bigger models and towards systems engineering. Harnesses, routing, tool use, test time compute, and infrastructure. The raw model still matters, obviously, but the differentiator increasingly looks like how you wrap it, train around it, and pay for it. First up, UK startup Inherent, founded by DeepMind-alumni, says its Faraday agent outperformed OpenAI and Anthropic systems on replicating scientific papers. That is a smart benchmark choice. Replicating research is much harder than answering a benchmark question or solving a coding task in a clean sandbox. It requires literature search, procedural fidelity, error recovery, and usually some tolerance for ambiguity in method sections that were not written for machines. If Faraday is genuinely stronger here, that matters because reproducibility is a useful proxy for one flavor of scientific agency. Can a system take a partially specified artifact and reconstruct the operational workflow behind it? The thing to watch is not the leaderboard claim by itself, but the evaluation design. Research replication is noisy, expensive, and easy to overfit with a clever harness. So the substantive question is whether Inherent has found a better scaffolding recipe, or whether it has exposed a real capability gap in today's flagship general models. Either outcome is commercially meaningful. If it's mostly scaffolding, that reinforces the idea that agent companies can still carve out value on top of foundation models. If it's a deeper capability gap, then domain-specific agent training becomes the next serious battleground. Next up, Nvidia published work that effectively makes the case that the harness, not the frontier model, is now the real hero in many agent settings. The claim is that with the right fine-tuning and orchestration, agents can perform well and avoid going off the rails, even if the underlying model is not especially strong at the task. That should resonate with anyone shipping production copilots. A lot of failure modes in agents are not pure intelligence failures. They are control loop failures, bad decomposition, poor tool selection, weak state management, and no guardrails around retry behavior. This is strategically important for two reasons. One, it compresses the advantage of owning the absolute best base model. Two, it rewards platform teams that can build reliable harnesses, observability, and offline eval loops. In other words, some of the moat is moving from pre-training to systems architecture. Nvidia is also very much talking its own book here, because better harnesses mean more inference workloads spread across a wider set of models, which is good for GPU demand. But that doesn't make the point less true. Staying on the engineering side, one of the stronger AR14 papers in the batch is learning when to think. The idea is simple and useful. Instead of giving every query the same reasoning budget, the model learns to choose between a no-think, short, or long mode as the first token of its response. That choice is learned inside the reinforcement learning loop rather than bolted on as a separate router. For architects, this is exactly the direction test time compute needs to go. Fixed reasoning budgets are economically dumb. You overpay on trivial requests and still underthink on hard ones. If this line of work holds up, it has direct implications for latency SLOs and cost control in enterprise deployments. You can imagine policy layers that allocate reasoning not just by predicted difficulty, but by business value, user tier, or workflow criticality. More broadly, adaptive reasoning is one of the cleaner ways to improve the compute capability trade-off without retraining giant models from scratch. Related to that, there's a paper called MidTool on mid-training data synthesis for agentic tool use. Mid-training has become one of the more interesting layers in the stack because it sits between broad pre-training and narrow post-training. The pitch here is to construct a large corpus that teaches general tool use using a mix of web, PDF, code, and synthesized supervision from real-world APIs. That matters because tool use is still weirdly brittle. Models can often describe the right action, but fail to execute the sequence reliably when API schemas drift, argument constraints matter, or the task spans multiple steps. MidTool is notable because it treats tool competence as something you shape before fine-grained instruction tuning, not after. That's probably right. If tool use patterns are baked into the model earlier, you may get more robust action priors and less dependence on prompt gymnastics at deployment time. Expect more work in this area, especially from teams who try to lower the cost of building useful agents without frontier-scale post-training budgets. Another worthwhile paper is Task-Co-Evolve, which focuses on harness optimization itself. The insight is that if you're iteratively improving an agent harness, evaluating against the exact same fixed validation task set every round is wasteful. Some tasks stop being informative as the harness evolves. Their method adaptively selects validation tasks, so the eval remains discriminative while costing less. This sounds niche, but it is actually central to how mature agent teams will operate. Once you accept that the harness is a product surface, you need efficient continuous evaluation for the harness, just like you need CI for code. Cheap, adaptive eval loops are how agent engineering becomes a discipline instead of artisanal prompt tweaking. On the model architecture front, Deadless 150M is one of the more refreshing papers because it starts from deployment constraints instead of scaling law ideology. It is a 150 million parameter small language model designed for CPU inference, with full attention in only 6 of 18 blocks and short convolutions in the rest. Translation: it avoids paying the full KV cache tax across the whole network. For local and edge scenarios, that is exactly the sort of hardware-aware design people have been asking for. We have spent years pretending every model should look like a shrunk frontier transformer and then act surprised when it performs badly on commodity hardware. This does not mean convolution hybrids will suddenly replace transformer-heavy small models across the board, but it is a useful proof point that architecture search should be much more deployment-specific. If your real target is a single user, quantized, CPU-only inference, then optimizing for that from day one is simply better engineering. On the market side, Nvidia partnered with data center developer Cloverleaf, another sign that AI infrastructure competition is now constrained as much by physical build-out as by silicon roadmaps. Power, cooling, land, interconnect, and permitting are now first-order variables in the AI stack. Nvidia is not just selling chips into this environment. It is increasingly helping shape the environment itself. That should worry anyone betting that model providers can scale independently of infrastructure bottlenecks. The stack is becoming vertically entangled. The more scarce power and build capacity become, the more advantage accrues to firms that can pre-coordinate the whole supply chain. And finally, OpenAI said California should strengthen its AI safety bill, SB 53. The policy detail matters less than the posture shift. Frontier Labs spent a long time resisting broad regulation, especially anything that looked premature or technically naive. Now the game is more subtle. Accept that regulation is coming, then try to shape it so it lands on model thresholds, reporting regimes, and safety process requirements that incumbents can absorb more easily than challengers. That does not automatically make the regulation bad, but it is worth being clear-eyed about the incentive structure. Compliance can function as safety policy and market structure at the same time. What to watch this week? Whether more vendors start talking about adaptive reasoning as a pricing primitive, whether agent startups lean harder into research and enterprise workflow replication as their wedge, and whether infrastructure announcements start sounding more like utility deals than tech partnerships. The technical frontier is still moving, but the operational frontier may be moving faster. That's your briefing. We'll see you tomorrow.